let's talk about the energy that comes in from the sun because it plays an important part in making the weather. Okay. Now, I don't know in building in Panama or Arizona if they use a lot of insulation in the houses. I know when I lived in Massachusetts and Utah and Colorado and Alaska, we used insulation in the walls. Okay. And I bring that up because if you look at that first bullet, way to the right hand side, I have the word insulation with the letter U in it. I'm going to distinguish that from this thing called insolation, which is kind of a mashed together abbreviated version of incoming solar radiation. Insolation, not insulation. I want to make the distinction. So the sun warms up the earth by a process called radiation. It sends, in addition to light, all kinds of radiation, electromagnetic radiation. And we talked about last time how the wonderful magnetic field around the earth protects us from pretty much all of it. And then we have the ozone layer that does a nice job of filtering out specifically the ultraviolet C radiation. You ever been shopping for sunglasses? You may have seen that little sticker on the lens that says UVA and UVB. You've probably never seen a UVC sticker because the ozone takes that out for us. Your sunscreen that you put on, UVA, UVB. But all of that radiation that does get to us does help warm up the earth. Now, the way it warms up is a function of several different things. How far we are from the sun, the tilt of the earth, where the actual land versus water is on this ball called the earth, and cloud cover. So let's take a tour of these four. Let's start with the distance from the sun. And Dr. Weil drew a nice picture and he defined some terms. He defined aphelion and perihelion. And in this picture, aphelion, it's when we're farthest away from the sun. And perihelion is when we're closest to the sun. Now note, in this picture, the date associated with perihelion, the time of the year we're closest to the sun. This is January. And then aphelion, when we're farthest away from the sun, is out there in the summer months.
Christmas in July.
Well, which kind of leads to the question is, in general, is it warmer or colder in the summer for us?
Warmer.
Yeah. And yet, look at this picture. We're farther away from the sun.
Well, and doesn't that have to do something with the fact that might be farther away, but the sun is shining more directly on our particular continents or on our particular hemisphere? due to the tilt of the Earth and its direction
Well,
of the sun?
yeah, and the tilt does play into this. And you're right. Now, the interesting thing is most of us experience getting things warmed up using a process called conduction, right? Which means there's two things that are actually in physical contact. When you put that skillet on your stove, right, and you turn on the electric burner, you turn on the gas burner beneath it, there's physical contact between the heat source and the thing that's being heated up. Radiation is different. Radiation transfers energy primarily by the amount of time that you're exposed.
Professor, could you repeat that, what you just said?
Radiation, the amount of energy transferred by radiation is a function of the amount of time that you're exposed to the radiation. It's not a function of how close or far away you are. It's a function of how much time you're exposed to the radiation. And Joseph, you are right on, because the tilt of the Earth is actually going to play a part in how much time we in the Northern Hemisphere are exposed to the sun and its radiation.
Yay!
So let me segue to the tilt. All right? Let me walk you through this picture. We've got the sun. And please note, this is not to scale. As if I had to say that, but, for the sake of correctness, it's not to scale. On the left-hand side of the picture, notice it's labeled summer in Northern Hemisphere. At the bottom, it's labeled winter in Southern Hemisphere. This is June. Over on the right-hand side, top, above the Earth, winter in Northern Hemisphere. At the bottom of the picture, summer in Southern Hemisphere. And for George in Panama, it's all the same.
The clock always goes dark. Like there's none of this nonsense that the sun goes out at 4 in the afternoon or 2 in the afternoon or 10 at night. None of that.
When I lived in Alaska, um, it was very interesting because during the winter, sunrise was around 10 a.m. and sunset was around 3 p.m. in Anchorage, Alaska. And then in the winter, it was flipped. Okay, we had in the in the winter we had uh, or summer I should say was flipped. We had super long days during the summer and super short days during the winter. But anyway, but that exaggeration can help us understand what's going on. Okay? In the winter, okay, the amount of hours that the sun is shining on us in the northern hemisphere is much less. And remember I said radiation, transfer by radiation is a function of how much time you're exposed. So we're exposed for a shorter period of time during the winter here in the northern hemisphere. So we don't get as much energy transferred to us. And it's not a function of how close or far away from the Earth or from the sun we are. It's a function of how much time we are exposed to the sunlight. Now, southern hemisphere, flip exact opposite of what's going on. And the tilt actually exposes more of that northern hemisphere during the summer months. And it has more dry land. And we'll talk about land breeze and ocean breeze and how the fact that water and land heat and cool at different rates. We'll get to that in a little bit. But all of that is going to contribute to the weather. All right, a couple more data points as we go around the sun. We have these things called the solstices. Summer solstice, somewhere around the 21st, 22nd of June. Depends on the year. That's when the Earth's path around the sun positions the Earth so that every part of the northern hemisphere gets more than 12 hours of sun. And conversely, the southern hemisphere gets less than 12 hours of sun. Then flip it over. Let's go to the winter solstice. Somewhere around the 21st or the 22nd of December. Yes, I said 21st, depending on the year. It's when the path of the sun, or the path of the Earth around the sun, puts the Earth in a position so that every part of the northern hemisphere gets less than 12 hours of sun. And conversely, southern hemisphere, they get more than 12 hours of sun. And again, remember, thermal energy coming from the sun is radiation. It's a function of how much time you're exposed to the radiation.
So you say that about time and exposure. And just a comment. My wife and I have been getting up at 6 in the morning to walk every day. And I've talked to her about, I have a feeling that if the sun was out for a couple more hours, we'd be freezing to death because it's super cold. I mean, for Panama, like it's 69, 70 degrees at 6 in the morning, but within 30 minutes, it just goes up super hot because the sun's up. So I was thinking, like, if the sun were to hide for just a little bit longer, like maybe 3-4 hours more, we'd probably be down to the 40s or 50s. So that makes sense. Thank you for that. I'll talk about it.
And it's just the basic. I teach physics as well. I mean, it's heat transfer. And we covered in a lot of detail in a physics class, but that's good. You're grasping the basic concept. That's good. It's part of the way God set up the universe to operate.
I'm having a hard time grasping the fact that he said that 40, 45 is freezing.
Yeah, my fridge isn't set that low. Like that would spoil the fruit.
It's in the mid 50s here today, and I'm loving it. Alrighty, so that's solstice. Let's talk about this thing called equinox, and that's not a type of gasoline that you buy. Guess what? We've got solstice, winter, summer. Guess what? We got equinox, spring, and autumnal. Yes, that's how you pronounce that word, autumnal. Equinox, equal. They have basically the same root word. So at the equinox, we have equal hours of daylight. It happens in the spring and it happens in the autumn. And for you, George, the equinox is when the sun is exactly over the equator. I've had the privilege of going to Singapore several times, and similar to Panama, in Singapore, it seems like no matter what time of day, no matter what day of the year, the temperature is always somewhere between like 70 and 85 degrees. Now, you've said you've had some cooler weather. That's interesting. But at the equator, you don't get a lot of variation in temperatures. All righty. What's interesting, and I like the kind of the little sidebar that Dr. Wild goes on page 164. He points out that all four of these events, the two solstices, the two equinoxes, okay, were celebrated as holidays by different pagan religions. Pagan sun worshippers, S-U-N, in the Northern Hemisphere used to celebrate December 25th as the birthday of the sun, the S-U-N. And despite the fact that the days in the Northern Hemisphere start getting longer after that winter solstice, the pagans didn't actually notice until a few days later on Christmas, what we know of as Christmas. Okay? Now, when they observed the days getting longer or getting shorter before the winter solstice and longer afterwards, they actually thought the sun was being reborn on December 25th, and they celebrated it as a holiday. So when the Christians came and witnessed to these pagans, they changed the holiday into the birthday of the sun, S-O-N, which is why we celebrate Christmas in December, even though early church literature seems to indicate Christ was born in April, kind of closer to the Easter time frame. All right, so we've talked about the thermal energy as a function of the distance of the sun. We've talked about the axial tilt. All those. Let me introduce you to this thing called convection. Maybe you've heard of convection oven. The way a convection oven works is that when air gets heated, it rises. It becomes less dense, it rises. And when it cools off, it sinks. Well, you've got the sun heating up our air, so it rises, but as it gets farther away from the actual surface of the earth, it eventually starts cooling off, and so it sinks. And so convection is causing air to rise and sink and rise and sink and rise and sink. That contributes to weather. We're just moving air around.